So I get the fortunate experience to work in our CTO office in Google Cloud, where I get to work both with our research and development teams, core product engineering teams internally, and then collaborate with partners externally across industry, whether that's non-governmental organizations, governmental organizations, corporations and industry that are really trying to drive some of the change that we need in order to save the planet. I recognize that Google is basically in its 8th year of the AI era with the release of Gemini. And we've been working in this space for a very long time responsibly. It is really important that we are taking these capabilities and techniques that we have and applying them to help solve some of the climate challenges that we face today. Now, there are areas where we do this, focused on kind of information for our users, optimizations for existing systems, and predictions to help us make better responses to climate change. And it does require us to take a very strong focus on the resource utilization that is required to perform some of these activities and capabilities. So if we think about, kind of the way that we apply AI from an information perspective, you can look at Google Maps, where we've released capabilities like eco-friendly routing, that you can actually make a behavioral change decision to choose to take a different route based on the energy and emissions impact of that route, whether that's for combustion engine vehicles or EV vehicles. We're also starting to use AI to summarize EV charging station capabilities so that EV drivers can become a little bit more effective in their route planning and optimizing as well. One of the other areas that we're spending time from an optimization perspective is in research with things like Project Greenlight, where we're helping cities. We're working with 12 cities in a pilot right now at looking at stop and go traffic, because emissions at stoplights is higher than emissions for vehicles that are moving. So we've got pilots in place that are looking at kind of 30% reduction in stoppage time by optimizing when the lights turn green with city operators, and making that in a way that they can then plug it into their existing systems and not have to completely drop and rip and replace everything that they're doing from an operations perspective. Another really important area that we're working on is in predictions. So we've done a lot of work around flood and flood model forecasting, but also in wildfires, right, where we know that a significant amount of our forest needs protection, and we've seen firsthand, certainly here in the Bay Area, we've seen it with the skies change. Our forests need monitoring and management, so we have been doing a lot of work on wildfire boundary mapping with AI, but then also are starting collaborations with the U.S. Forest Service around wildfire kind of expansions and predictions in that space. What is the surface area that we know will need additional protection, that will need enablement, that will need a different way of approaching resource management in those spaces? Now, all of these things, like, and Joel, the list of bullets that you put up at the front, I looked at that and I was like, yeah, we're doing some stuff there, we're doing some stuff there, we're doing some stuff there. Like, we could have a very long discussion about the things that Google is trying to use its AI power for in order to make a real world impact for positive humanity. But we do have to be mindful of the resources there. And so we do know that energy and data center utilization is super important to how we are developing and bringing these models to market. Google has a very ambitious goal of being operating on carbon-free energy 24/7 every hour of the day for our data centers and facilities by 2030. That was kind of a scary goal when we set it, to be quite frank. Like, that's a very strong commitment to make. We now have some of our about 64% of our data centers are operating at carbon-free energy. We have 20 data centers that are operating at 85% carbon-free energy or more every hour of the day, and 7 that are operating over 90% carbon-free energy. Now, this is not perfect, right? We need to get to a place where that is everywhere that we are operating. We also know that we are expanding our operations in order to support the AI models that we're building, training, and running inference on, that are powering some of the capabilities that will help us reduce emissions, but are also empowering the use cases that we hope everybody here is working towards to solve the challenges that we face. So the focus on carbon-free energy is a very big, important part of that, but also it's kind of how we manage the models and how we're thinking about developing AI and bringing that to market. So we're kind of taking a 4Ms approach to this. One is the model and the model architecture itself. How do we look to find those efficiencies in the model architecture, and then also in model selection and application? You might not always need the largest foundational model to solve a very small optimization problem. That would be overkill, and that it is an extraordinarily high use of energy for a use case that could be solved more effectively. The second is in the machines. So we've developed our own tensor processing units, we've developed our own custom accelerators that we know have helped us both train and inference faster. We're also working with our industry partners like NVIDIA on bringing on board the newer chip models as they come out, which do have a reduced energy footprint for both inference and training. That's extraordinarily important, as it's not just the work that we are doing, but also from a Google Cloud perspective, the work that our customers are doing and the workloads that they're bringing on board. The third part of this, I would say, is map optimization. So we have multiple data centers, not all of which are running at 100% carbon-free energy today. How can we look at where the energy used is optimized for the workloads that we're running? So we do things like load shift the times of day that we're running these training model trainings and inferences. We do things like load shift which data centers they're operating given the time of day. So, another I could talk forever on this topic, but another optimization there is like, predicting wind so that our data centers that are powered by wind, we can have a 36-hour forecast to know, like, maybe we should actually be running that training here now or moving this load to a different region because we know that we're not going to have the wind energy at those hours of the day that we're running those workloads. So I think it's really important, and we got model. Did I get all the 4 M's? We got model. We got the fourth is mechanization, right? Like, what are we doing from a data center utilization perspective and the power usage efficiency of those data centers itself? We have been optimized through artificial intelligence, machine learning. I can tell them about it. Get the hook here. But I think the one thing that I want to leave you with, I think it's extraordinarily important as these workloads go in utilization, that we as providers of these services are also extremely focused on the impact of the usage of these tools and technologies that we put out, and it's imperative for us to make the change there.
Great, thank you very much.